Hello everyone, welcome back to Infinity Physics. In the last lecture, we had a discussion about Mendeleev's periodic law. So if you have not watched the previous video, watch it. It will be very helpful to understand the concept and also it will be helpful in your examination. In this lecture, we will discuss about achievements of Mendeleev's periodic law. So take out your notebook and note down the important points. So what are the achievements? So elements were classified on a more fundamental basis of their atomic mass and properties. Fundamental means the property that possessed by all the elements, right? So here you can see that all the elements were classified according to their atomic mass and they arrange and all the elements arranged by the Mendeleev in the increasing order of their atomic mass, and he grouped the elements on the basis of their similar chemical properties. Spaces were left vacant to accommodate the elements to be discovered in future. So here you can see that he left some spaces, right? And he boldly classified that in future more elements will be discovered and some elements will be placed here, and he also predicted the properties of that element which had to be placed here. So you can see here Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral eka to the name of the preceding element in the same group. So here you can see that Mendeleev boldly predicted that in a near future a new element will be discovered, and that element will be having atomic mass 68. Formula of his oxide is E2O3 and formula of his chloride is ECl3. But at that time he had given a name by himself to that element, that is Eka aluminium. And in the near future new element discovered, and scientists found that the properties are similar that were predicted by the Mendeleev, right? So here we can prove that Mendeleev was very right, and scientists named that element gallium. Similarly, Mendeleev also predicted the properties of the other elements like gallium, right? Here gallium, so you can see eka aluminium, then eka boron. Eka boron, nowadays it is known as scandium. So Mendeleev predicted the atomic mass of eka boron 44, and then it was discovered and the mass found is 44.95, and scientists given name that element scandium. Similarly, he also predicted the atomic mass and properties of other element known as eka silicon. So Mendeleev named that element eka silicon. Nowadays it is known as germanium, right? So here you can see that how smart was Mendeleev, and that's why he is known as the pioneer of the periodic table. The inert gas elements discovered later could be placed in a separate group without disturbing the table. So here you can see that it is the Mendeleev's periodic table. So in the near future, that is after the Mendeleev, new element, that is a group of element, that is we can say noble gases, helium, neon, argon, krypton. So all these elements are called noble gas elements. So when these elements were discovered, they placed in a separate group, and they had not disturbed the Mendeleev's periodic table. So here you can see the periodic table, modern periodic table, and here there is a group, right? And this is the group of noble gas, and without disturbing the arrangement given by the Mendeleev's periodic table, right? This group was placed separately. But also there were some of the defect, or we can say some of the limitations, some of we can say little mistake was made by the Mendeleev. So what are that mistake? Some elements are not arranged in the increasing order of their atomic mass. So here cobalt and nickel, tellurium and iodine, etc. So here you can see that where tellurium and iodine, the atomic mass of tellurium is 127.60 and iodine is 126.9. So if he is arranging the elements in the increasing order of their atomic mass, then iodine should be placed before tellurium and tellurium should be placed after iodine, but he placed like this because he found that the properties of iodine is more similar to this group and property of tellurium is more similar to this group. So instead of placing tellurium here, he had placed this like this. Similarly, cobalt and nickel. He also found that the chemical properties of nickel is not similar to this group, right? So he had to placed the cobalt before nickel, and nickel he had to placed in this group, right? So because of the chemical property, he had to place the elements in this arrangement. He had not placed the elements in the increase, that is, he had not followed his own law. What law he had made? He had made that all the elements are arranged in the should be arranged in the increasing order of their atomic mass, but here he is not following his own law, he is breaking the law, right? So that was the limitation. Then the atomic masses do not increase in a regular manner in going from one element to the next element, so it was not possible to predict how many elements could be discovered between two elements. So here you can see any of the element. Here you can zinc, right? And here's 74. So here 65.37 and the atomic mass of astatine is 74.92. So if this atomic mass is 65.37, then it is possible that in the near future new element will discovered has the atomic mass of 66.5. Then next element will be having mass 67. Then next element will be having mass 68.5, right? So in between, how many elements will be found in the near future, you cannot predict, right? So that was the problem with the atomic mass. But if we consider the atomic number, you are very familiar with the atomic number, right? So if we consider the atomic number, then it will be very easy. For example, here the atomic number of lithium, atomic number means number of protons inside that element, inside the atom of that element. So here lithium has atomic number 3, beryllium has 4 because it has only 3 proton, it has 4 proton, it has 5 proton, it has 6 proton, it has 7 proton. So we can arrange them in a regular manner, right? So we can say that there will be no other element will be found, that is you cannot find elements having half proton, that is all the elements will be having full protons, right? 1 2 3 4 5 like that wise, right? So if we try to classify the elements on the basis of their atomic number, that is number of protons, then we can say that how many elements will be there in between. That is, for example, here we have hydrogen, right? Hydrogen atomic number is 1, you know that, right? Then atomic number of lithium is 3. So we can predict that there will be only one element in between this, which is helium, that is atomic number 2, right? Similarly here the atomic number of zinc is 30, right? So if then we can say that here the element having proton 31, that is atomic number 31, and here atomic number 32, and this astatine having atomic number 33. So we can say that there will be only two elements will come in between this two element. So with the help of the atomic number, we can exactly predict how many elements will be there between these two elements. But with the help of atomic mass, we cannot predict the number of the elements between these two elements. That is here, as we discussed earlier, here 65.37 mass is there, and here 74.92 mass is there. So how many elements, if we consider the atomic mass, then how many elements will be there? We cannot clearly identify, right? So that was the problem with the Mendeleev's periodic table. Similarly, position of the hydrogen is not clear because it shows the properties similar to the metals as well as non-metals. So what are the properties of metals? Metals lose electron, non-metals gain electron. So in the Mendeleev periodic table, hydrogen was not classified properly, that is where hydrogen should be placed, right? Now the position of the isotope of the element is not clear. What is isotopes? Isotopes are the element having same atomic number and different atomic mass. That is, if you have carbon, then C16, C6, C12. That is, here 612, 6 indicates its atomic number and 12 indicates its atomic mass. Similarly, C13, atomic number 6. C14, atomic number 6. So what is the common in between them? That their atomic number is common. All have atomic number, that is number of proton is 6, but all have different atomic mass. So if I am arranging the atomic on the basis of their atomic mass, then I have to specify 3 different position to the carbon, that is one position for C12, one position for C13 and one position for C14. But if I use atomic number, then the one position of carbon will be helpful to determine all the position of other carbon, that is all the isotopes of the carbon. So here, instead of writing these elements, instead of considering their atomic mass, if I consider the atomic number, that is C6, that is carbon having atomic number 6, then it represents the all the isotopes and itself also. Similarly with the oxygen also, oxygen has 3 isotopes, 16, 17 and 18. But if I write O8, then this O8 represents all the other isotopes of the oxygen. So instead of classifying the elements on the basis of their atomic mass, if we classify the elements on the basis of their atomic number, then it will be very easy for us to determine the position of the element. So here, this is the modern periodic table, and you can see here all the elements are classified on the basis of their atomic number, not mass. So all these things we will discuss in the next lecture. Have a nice day.